Getting this here, so you type them in with the calculator like I kind of showed you before. And so then now what we're going to do is we're going to do the same thing, but with the top one. Then we're going to compare red graph into this one in black. Okay, so then I'm going to take my calculator for this one. This is how it's going to look. Have to have this one half and this 1/4 will have to be in parentheses. So that's how you have to do multiple fractions. This is what it'll look like. So 1/2 times 1/4 to the negative second power is going to be 8. Okay, we're going to do the same thing, but now instead of -2, I'm going to have -1. Get 2. Same thing, but instead of -1, I'm going to have 0. And 1. And then 2. 0.03125. Now, as those decimals get smaller and smaller, if they happen, just understand that you're not going to get the perfect one. You're just going to have to try to keep them pretty close to the x-axis as you can. So let's graph this first one. -2, 8. -1, 2. 0.5. 1.125. And then 2.3125. So that's a pretty small one here. Okay. So we know the top one from red to black was a vertical stretch. It stretched every point with a scale away from the x-axis with a scale factor of 4. What's this one doing? We know the other one was a vertical stretch. This one's stretching it still. Is it stretching it away from red to black? From the x-axis? No, it's not. What might be a good word for that? It says stretch. Shrink. This is a vertical shrink. So if you look at all of these ones, all the points are shrinking towards the x-axis vertically, right? So you take them all and they shrink. Oh, so this would be a vertical shrink. With the scale factor of what? What's that scale factor? Half, yeah, perfect. Right, because look, all these numbers, 16 times a half is 8. 4 times a half is 2. 1 times a half is 0.5. And so all of these points are half the distance between the red dot and the x-axis. That's exactly in between. Okay. Okay. So we're gonna do a little page. We're gonna go all the way to the very front page. We're gonna start creating ourselves a little organizational tool to help us keep this all straight. And because there's just a nice little dead space down here that we'll use, okay? Right in the dead center, this is what it's gonna look like. Y is equal to A times B to the X power. And we're gonna add more to this, just right in the front. Okay, A value. With that A value, what are the two different things that A value can do for you? So based on the page that we were just on, right, the one we were just working through, what are the two different things that that number out front can do to us? What are the transformations? Vertical stretch and vertical shrink. How can I look at that A value and tell whether it's going to be a stretch or a shrink? Okay, so I'm going to let you guys finish writing this, and then I'm going to go back to that page. Because we had an A value here that was 4, and that was a stretch. And we had an A value here of a half, and that was a shrink. How can I tell? When is it a stretch and when is it a shrink?
Anything above 1 is a stretch.
If my A value is greater than 1, it's going to be a stretch. So if I have an A value of 1.01, that's going to stretch it away from the x-axis. It's going to make it bigger. Okay. Vertical shrink is when A is in between 0 and 1. Okay, not positive or negative. If it's in between 0 and 1, it's going to shrink it down. It's going to shrink it towards the x-axis. So this is valuable information because I'll let some people, I see they're still writing. A problem like this here that we did here, this is going to be worth 8 points. It's going to be 4 points for the graph that's in black. Okay, you will not be required to do the graph that's in red. And then 4 points for being able to tell me what the transformation is. Now, if you can look at the A value and say, I know it's a vertical stretch, you already have 4 of your 8 points. And you don't have to do anything. But if you don't know those, then now you're looking at, you're going to have to do 2 different graphs just to figure it out. Okay. So A value, it's between 0 and 1, it's a shrink. If it's greater than 1, it's a stretch. Okay. We're going to try to do, there's 3 total transformations we're going to cover. We're going to try to cover 1 more today. We'll call it a break, and then we'll finish up the last one and put them all together in the next class. So let's go to 6.3, page 5. Okay. Now on 6.3, page 5. Okay, the first thing I want to do is identify the parent function. The parent function here would be y is equal to 1/4 to the x power. Okay, if you look on your previous page, we actually already graphed that exact parent function once already. So let's just take a second and copy that. We don't have to retype that all in. We already did it once. So let's just go ahead and just copy that previous one here. Let's see if I can do it in my head. Oh, this will be 16. This will be 4. This will be 1. Yep. 625, 125 or 6. I'm on spot with these graphs. These look good today. Sometimes they're all
Yeah.
chunky and curvy and all over the place, but
No.
they are. We'll do parabolas eventually too. Those are tough to draw at times. Okay, so I'm just not going over how to do this because we already did this exact graph earlier. Okay. All right, now we're going to do the top one. The X values, these are the ones where the X values are going to change. I will explain to you kind of when we get to the bottom example, how to tell when the X values change and how to figure out which ones are the ones you want. Okay, but just for the time being, just kind of tag along with me. Okay, so the X values we're going to plug in here are going to be -4, -3, -2, -1, and then 0. And I'm going to show you how to type this in. Because look, the only difference between the parent function and this one is there's a little +2 in the exponent. So now what we're interested in is we're not interested in that A value at all. We're interested in what does that +2 inside the exponent do to our graph. So let's find out. Okay, so I'm going to take this, I'm going to do the 1/4, and then I'm going to raise it to the X +2, and X is -4. So I have to go -4 + 2 in the exponent like that. So that is how my exponent is going to have to look. If you go -4 and then +2, you're not going to get the right thing. And I get 16. That's pretty nice. Okay, so now I'm going to do the exact same thing. 1/4 to the, but instead of -4, now I'm doing -3. Then I'm going to enter, and I'm going to get 4. And I'm starting to come to a realization that 16 then 4 look pretty familiar. If you had to guess what my next 3 numbers are going to be, what are they going to be? 1, okay. You're right. 1.25, you're right. These numbers are actually the same because there's no stretching or shrinking going on, although the graph does change. So let's go ahead and graph this. -4, 16. That's right here, I believe. -3, 4. Here's -3. Here's 4. -2, 1. Here's -2. Here's 1. -1.25. Here we go. And then 0.0625. That's pretty low. So we're just going to call that good. Well, this one's pretty bad start. I salvaged it. All right, what's the transformation? What's happening from red graph, black graph? Okay, now I can eliminate a vertical shrink because they would all have to shrink by the same factor. And like this one has a factor of 16 because this is at 1 and this is at 16. This one's at 4 and this is at 1/4. It's just not quite doing that. I heard somebody say it. Look at all these dots. 1, 2, left 2. This dot, 1, 2. This one, 1, 2, left 2. This one, 1, 2. And then this one, 1, 2. They are all being translated left 2. Every dot is in the same spot as the other graph. It's just being moved to the left 2. Okay. So why do you think it was left 2? Well, I had x plus 2 here. And what did it do? Moved it to the left 2. So let's try to do a little bit of problem solving here. We know x plus 2 in the exponent moved it to the left 2. What do we think a minus 1 in the exponent for this one's going to do? It's going to move it right 1. Okay, so what I'm going to do is I'm going to graph the parent function pretty quick. Okay, the parent function for this one is, again, just the b value to the x power. So 3 to the x power. And I'm going to graph this parent function not as fast as I can, but I am just going to do it in my head really quick, okay? Because I'm kind of at the point where I'm assuming you can figure out how to plug the x values in and get the y values. Kind of walking around to look like most people were able to use a calculator for that. Okay, so 0.1 repeated on -2. 0.3 repeated. 0, 1, 1, 3, 2, 9. Okay. We've already came to the conclusion that this graph is going to look the same as the red one. The only difference is everything's being moved to the right one. So knowing that it's being moved to the right one, I have to take my regular x values and move them to the right one. So if I'm at -2 and I go to the right one, what x value am I at now? So if I'm at -2 and I just go to the right 1 unit, what number am I at now? -1. So this graph is going to start at -1. And then +1, +1, +1, +1. Okay. So this is very important because notice at the beginning of the previous one, I just said, hey, trust me that I know we had to do at -2. It's because I knew that this graph here was going to be translated to the left 2. So I started at -2 like I always do, and I moved to the left 2. If I'm at -2 and I move to the left 2, what number am I now at? -4. Okay, so now what you can do is you could type these in one by one, but we know that everything's going to be the same in this particular circumstance. All we have to do is move everything to the right 1 unit. Okay, we have one last thing we're going to do before I give us a little break is we're going to go back to the front page and we're going to discuss what is now going to be called the H value. Okay, so now what we have is we have this a times b to the x power. What I am going to do is I'm going to add the H value in here. Actually, I'm going to minus the H value, not add, in the exponent. So now we're building this basic form, a times b to the x minus h power. Okay, and now we're just going to discuss the H value, which we just talked about on that previous page, H value. What are the two different things the H value can do for my graph? Move it left and right. You can write the word translate if you want to, just for the sake of time. I'm going to use left and right. It's going to move your graph just to the left or just to the right. How do I tell if it's to the left or if it's to the right?
If it's +2, it'll move left, and if it's a positive, it'll move left, if it's negative, it'll move right.
Okay. I've yet to have a class that hasn't said exactly what you said. But technically, and I'm going to explain why. When H is positive, it's right. And when H is negative, it'll move left. Now, that being said, H is going to look backwards. When it's positive, it's going to look like it's negative. And when it's negative, it's going to look like it's positive. It's really weird, and I can explain exactly why. But for some people, you might just need to do a little memorization that H is just a little bit backwards. And by a little bit, I mean a lot. It's 100% backwards. Here's why. Imagine I have an H value equal to 3. If I have an H value equal to 3, okay, I'm going to plug in a positive 3 here, and then I'm going to have b to the x minus 3 power. Well, now it looks like it's negative here, but it's actually positive. So it's backwards. Similarly, if I have an H value equal to negative 3, I'm going to plug in that, and now I have b to the x minus negative 3 power. Well, what do we know about minus negative 3? What is that the same as? Plus 3, positive. So this would be b to the x plus 3. So here it looks positive, but it's actually negative. And here it looks negative and it's actually positive. H is backwards. It just, there's a reason why it's like that. And I mean, this is it. But it still throws a lot of people off. So you might just need to memorize that. It's a little backwards. Okay. Okay, we have one more translation to figure out for next class. And then what we're going to do is we're going to have problems with its own A, H, and then eventually K value. And then we'll put those all together. So our learning targets will be done next time in class. Otherwise, there's nothing for you all to worry about between now and then.